We will now move to part 2 of Heron's formula. Again, we are continuing with the same section, introduction. In the last video, we discussed what all we will be learning in this chapter and recollected what is meant by perimeter and area. In this video, we will recollect formula for area of rectangles and basic formula for area of triangles and prove both of them. So now we are going to see proof of area of rectangles. Recollect what is the formula for area of a rectangle. Write down in your notebook and then check after I start, I continue. I am pausing for a moment. Yes, on a rectangular surface along one of the longer sides, let us keep a thin stick, say 1 mm thick and length equal to the longer side, say L mm. So in the next page, we will also see an example. Here you just understand the concept alone, the proof alone. So take a stick which is of 1 mm thickness and length equal to the longer side. So let us say longer side is L into B means B. So thickness should be 1 mm and length should be equal to L. Sorry, longer side is L. Now the space of the surface covered by the stick is equal to 1 into L equal to L. The unit of measurement we will see in the next page or in this page at the end of this page. Like this, if we keep B number of sticks, where B is the breadth of the rectangle, one after the other. So that means one stick we have kept. Now we are going to stack more and more sticks on the side, one after the other, side. You keep on stacking till the end of the other, the end of the breadth. The total space covered by the shape is equal to L into B, that is B times the space L. So initially one stick occupied a space of L, then if B times the space of L, if it is occupied, then we will see what is that. The area of the rectangle is equal to space occupied by the sticks area equal to L into B. So one stick has occupied L space, B sticks will occupy B into L equal to L into B or B into L. Unit of measurement of area is square meter, can be referred as meter square also or mm square, centimeter square, feet square. So now you can see the difference between perimeter and area. In perimeter, because we are only adding the lengths, so it is only meter. Here we are multiplying millimeter and millimeter or meter and meter, so it is called meter square. Therefore, in this proof, area of rectangle equal to L into B millimeter square, because we have taken 1 mm thick and B mm is the total number of sticks. So that we will see in the practical example, you will even understand better. For the time being, this is the proof for this rectangle, for the area of the rectangle. Now we will see an example. Let us take a rectangle of length 100 mm and breadth 10 mm. So L is 100 mm, B is 10 mm. Let us see the adjoining diagram. So this is a rectangle. Let's mark the points A, B, C, D are the vertices. Then L equal to 100 mm and B equal to 10 mm. Keep one stick of 1 mm thick and 100 mm length from A to B. The space covered equal to 1 into 100 equal to 100 mm square. So in the last page we saw L mm. So it was total space covered was by one stick was L mm square. Mm square I had not written there, I had written as L. So here, since the length is 100 mm and the thickness is 1 mm, the stick thickness is 1 mm, the total space covered by one stick equal to 100 mm square. So let us see, I am going to draw a line. So see the green line, one line I have drawn. Now like this, keep 9 more sticks one after the other. So side by side I am going to keep 9 more sticks. So what happens? The total space covered equal to, already we have kept 1, we are keeping 9 more, so total 10 sticks, and thickness of each stick is 1 mm. Area occupied by one stick is 100 mm square, area occupied by 10 sticks equal to 1000 mm square. So see the now rectangle, I am going to keep one by one. Let us start counting. 1 already I have kept. I am going to start 2, 3, 4, 5, 6, 7, 8, 9, 10. So now one stick I had kept, another 9 I have kept, totally 10 sticks I have kept. You can see the rectangle is fully covered with green lines. So the entire area is fully occupied by how many sticks? So 10 sticks. What is the space covered by one stick? 100 mm square. The space covered by 10 sticks is 1000 mm square. Therefore, area of rectangle equal to L into B equal to 100 into 10, 1000 millimeter square. So we are able to, through a practical example, we are able to prove that the area of rectangle equal to L into B. That is, L is the length of the rectangle and B is the breadth of the rectangle. So total it is equal to 1000 millimeter square. So the area of rectangle is equal to the space covered by 10 sticks of length 100 mm and width 1 mm. So that's how we are able to prove the area of rectangle. We'll move to the next page. If you have doubt, pause the video, note down these points. These are all very simple proof, and then we'll move to the next page. We'll go to the next page. So we are going to see area of triangle proof. Now we have seen the rectangle like last time. So now we are having a rectangle ABCD, length L and breadth B. ABCD is a rectangle of length L and breadth B. Mark points E and F on AB and DC equidistant from A and D. So what I am going to do, I am going to mark 2 points E on AB, F on CD such that AE equal to DF. Correct? So now that is equidistance. Join A and B to F to form triangle AFB. So now A I am joining to F, B also I am joining to F. So together it has become a AFB has become a triangle. Join F and E. Let us join F and E. FE is the height. So we will see the reason for this after 2 pages. Like why we are calling FE as the height, we will see after 2 pages. Now quadrilateral AEFD is a parallelogram. You can see that. I'll just show here. AEFD. So AEFD is a quadrilateral. The reason is a pair of opposite sides is equal and parallel. Remember the properties we have seen. Opposite sides AE. You see AE, which is nothing but AB, and DF, which is nothing but DC. Both are parallel because it's already a rectangle. In rectangle, AB is parallel to DC. Therefore, AE is parallel to DF. And by construction we have marked AE equal to DF, right? That is what is the first point we have done, mark equidistant. Since a pair of opposite sides is equal and parallel, one of the properties of a parallelogram, the quadrilateral AEFD is a parallelogram. So now we will move to the next page where we will see further on this. So now what we are going to do, triangle AEF is congruent with triangle FDA. So now what has happened, since this is a, I'll show this, since this is a quadrilateral and in that what has happened, a diagonal AF divides it into 2 congruent triangles. So this and this, these two are 2 congruent triangles. Now let us move to the next point. These are very simple proof. Similarly, BEF, triangle BEF equal to congruent to triangle FCB. That is, I will put double tick here, BEF and what is the other one? FCB. The reason is BF is the diagonal here and the parallelogram is BEFC. So due to this, what has happened? Now these two, you can now see single tick both are equal, double ticks both are equal. So now we have divided the whole rectangle into how many triangles? Yes, 4 triangles. Initially we made 1 triangle, now we have made it into 4 triangles to see the proof. So now area of rectangle ABCD equal to area of parallelogram AEFD plus area of parallelogram BEFC. So I will just erase only these things. I'll remove this, these 2 ticks I am removing. I am removing this tick. So now you can see if you add these 2 parallelograms, that is AEFD and BEFC, that is the area of the rectangle ABCD. So now we will go to the next page. In this page onwards, I am not going to say repeatedly rectangle and triangle shapes, and this symbol I am not going to put. If you see 4 alphabets, it is area of rectangle. If it is 3 alphabets, area of triangle. So now ABCD, that is a whole rectangle, equal to AEF. Now I will take it here. Let's see again. I will put AEF plus FDA plus BEF. So now I am putting double. You remember last page we have put double here, and FCB double here. So if you add all the 4 triangles area, it becomes the area of the rectangle. Now ABCD, that is whole rectangle, equal to 2 into AEF. There is 2 double ticks are there, plus 2 into BF. The reason is AEF equal to FDA and BEF equal to FCB. So now we can consider they are 2 into. So now I will change this. I'll put the erase. I'll just remove this. This I will remove. I'm going to remove this. I'm going to remove this. Now if you see what happens. Now this into 2, this into 2 becomes a whole area of rectangle, correct? Let's see the next line. Or ABCD equal to 2 into AEF plus BEF. So 2 I have taken it out, or AEF plus BEF I am taking 2 to the other side, ABCD. I will remove now all the markings. Now it will be clear. Or AFB equal to half ABCD. Why AFB? Because AEF, this AEF plus BEF equal to the total triangle ABF, correct? So AFB or AFB equal to half into ABCD. So we have got the proof, but we will go to the next page to see further. You can note down these points and then move to the next page. So therefore AFB equal to half into L into B, that is area of rectangle equal to length and breadth, because AFB we saw is half of the whole area of rectangle, or half into L into B. Area of triangle AFB equal to half into B into H. Let's see what is B and H. Length L is AB. You can see that I am putting a line here, red line here, that is base, and that is what is the length of the rectangle, and EF is the height. You can see the red line again, height. But how I am saying height H equal to B, because L into B is rectangle. Here we are now changing L to B because L and B are same. Whereas how I have told is, now if you see again in this parallelogram, we have proved this as a parallelogram. It is opposite sides are parallelogram or a rectangle. Opposite sides are equal. That is, this and this are equal. BC equal to EF. Therefore, what is BC? BC is B of rectangle and AB is L of rectangle. So now L of rectangle is nothing but base B of triangle, and breadth B of rectangle is nothing but height of triangle. So due to that, what happens? The area we have now got triangle AFB equal to half into B into H. That's how we have got the proof of this. You can note one point here. Although AEF, AEFD and BEFC are rectangles, we have referred them as parallelograms because there was no need to prove them as rectangles, because I have been telling, no, this is only we are using this, I am erasing all. We have been using the properties of parallelogram only, we never use the properties of rectangle. So thus we are able to prove the area of triangle AFB equal to half into B into H. These are all very simple proof. If you have doubt, note down all the points, go back to the previous page and thoroughly understand. Now let's go to the next page. So in this video, we recollected formula for area of triangles and rectangles and proved both. And we will check in the next video whether we can use basic formula for area of triangles for different types of triangles. Questions 3 in this page, 2 in the next page. So sorry, You can pause the video, note down the questions and then go to the next page. We'll move on. And there are 2 questions in this, totally 5 questions. Attempt all the questions in a single sitting. That's all for this video. Thank you.